Okay, so in this video we're going to go over the homework for the piecewise functions. Now I went over this one in class, but if you need it, I'm going to go over it again. 32, we have two separate functions here. We have f of x is equal to 3 of x if x is not equal to 0, and 4 if x is equal to 0. Now, for this video, I'm not going to do the graphing. I'm just going to do the domain, and I'm going to do the intercepts. If you want to see the graphing, just let me know in class. So f of x is equal to 3x. The domain here is if x doesn't equal 0, it's going to behave as 3x. So that means any other place besides 0, this function is going to exist behaving like 3x. At x equals 0, my function will still have a value. So what that really means is my domain is going to be all real numbers, since there's no the function exists for all x. Now, if I want to find the intercepts, if I find the y-intercept, I'm going to set x is equal to 0. So if I do the first function, this becomes y is equal to 3 times 0. And so y is equal to 0. However, like what Nicholas said in class, we actually shouldn't have even tried to solve it, because in this function, x cannot equal 0. So right here, the y-intercept doesn't exist. Okay. However, now if I look at the second function, at x equals 0, y is equal to 4. So at x equals 0, y is equal to 4, so that is my y-intercept. When x is equal to 0, y is equal to 4, so my y-intercept is 4. Now to find my x-intercept, I'm going to set y is equal to 0. So in my first function, this will become 0 is equal to 3x. And so 0 is equal to x. Okay. Now, however, if I look here, x is equal to 0, I have to go and check back at the restrictions. It says here x cannot equal 0. So when I arrive at x is equal to 0, I know that's not going to, at x equals 0, I'm not going to have a value, since 3x, x cannot equal 0. So when I arrive at x equals 0, I know this cannot be an x-intercept. Okay. Now, I need to check the second function, but the second function is kind of obvious. If I have 0 is equal to 4, 0 equal to 4, that cannot exist, right? That doesn't make any sense. So there is no x-intercept. So that's how you find the y-intercept, that's how you find the x-intercept. There's no y, there's no x. So now let's move on to number 34. So the piecewise function for 34, let me change the number here. I have f of x is equal to x plus 3 if x is less than negative 2. And then I have it's equal to negative 2x minus 3 if x is greater than or equal to negative 2. Now let's find the domain. My domain here is it acts like this function if it's less than -2, and then if it's greater than or equal to -2, it's going to act like this. So that means there is no minimum x value, there's no maximum x value, and at -2 I know that it will be continuous, and there will be a value at -2 because I have greater than or equal to. So that means at -2 I will have a value with the second part of my piecewise function. So my domain again is all real numbers. Now if I want to find the y-intercept, I need to set x is equal to 0. Okay. Now I check over here at my two functions. X is equal to 0 will not occur on the top function, right? Because here x will be less than -2. So my y-intercept can only occur on the bottom part of the piecewise function. So once again, since x is greater than or equal to -2, x is equal to 0 does fall within x is greater than or equal to -2. So this is the only one that I need to check. Okay? So my y-intercept is y is equal to -2 times 0 minus 3. Y is equal to -3. Okay? So that is my y-intercept, -3. Now to find my x-intercept, I set y is equal to 0, and I need to check it for both parts of the function. So I'm going to have 0 is equal to x plus 3. I subtract 3 from both sides, and I get -3 is equal to x. I have to go back and check, does this fall within the parameters of the piecewise function? So x is equal to -3. If it goes to the top part of the piecewise function, does it belong in the domain of the top part? Well, x is less than -2. Since -3 is less than -2, this one is going to be an x-intercept. It works. Now I also need to check the bottom one and see if I have another x-intercept. So I have 0 is equal to -2x minus 3. I add 3 to both sides, and I get 3 is equal to -2x. Divide by -2, and I get -3/2 is equal to x. Now I need to go and check back that -3/2 falls within the domain of this bottom part of the piecewise function. So x is greater than or equal to -2. Now, -3/2 is really -1.5, and -1.5 is greater than -2, right? So this is an x-intercept. So you have two x-intercepts here. You have x is equal to -3, and also x is equal to -3/2. Those are your x-intercepts. Okay. So let's move on to 36. So 36, you have f of x is equal to 2x plus 5. If -3, I believe, and then the last part is -5x x is greater than 0. Okay, now let's do the domain here. The domain now, remember my domain is my lowest x value to my greatest x value. So my lowest x value, I have -3, so I know that's the, my x value is not going to go to the left of -3. Okay. Now I know it's going to keep going at 0, it's going to stop for the top part, but I know it's going to have a value at 0 since it's a -3, and then it's going to continue after 0 and have no end. So my domain will start at -3 and it will go to infinity. Okay. Another way you could say this is all x such that x is greater than or equal to -3. Okay. So now let's find the intercepts. Let's find the y-intercept. Now my y-intercept is when x is equal to 0. So if I look here, I only have to really just check for when x is equal to 0. X is equal to 0 only at this middle part of the piecewise function. I have x is equal to 0. So x is equal to 0, y is going to equal to -3. That is my y-intercept. Now, my x-intercept is when y is equal to 0. So we have 3 different parts to check it. The first part is y is equal to 2x plus 5. If I subtract 5 from both sides, oh, sorry, there should be 0 is equal to 2x plus 5. So if I subtract 5 from both sides, I get -5 is equal to 2x. I divide both sides by 2, and I get -5/2 is equal to x. Now, does that fall within the domain of the top part of my piecewise function? Well, -5/2 is really -2.5. And -2.5 falls in between -3 and 0. So this is a correct x-intercept. Okay? So I'm going to put a check mark there saying that this is the correct one. Now, if I put it in the middle one is one that we probably shouldn't be checking too often. You should be able to tell me that 0 is equal to -3 does not make any sense. So that is not going to be an x-intercept. Now, if we check the last part, I'm going to have 0 is equal to -5x. And so x will be equal to 0. Now, if I go back and I check here, if x is equal to 0, that does not fall under the domain of the last part of the piecewise function. X needs to be greater than 0. Here I have it equal to 0. Okay? There's no greater than or equal to sign here. So this is not an x-intercept. So your only x-intercept here is x is equal to -5/2. Okay. So now let's go to number 38. 38. Okay. F of x is equal to 1 over x, so it's a reciprocal function if x is less than 0. And then I have the cube root of x if x is greater than or equal to 0. Okay. My domain here, I have it exists for the top part of the piecewise function. Any value less than 0 is in my domain. And on the bottom part, any part greater than or equal to 0 is my domain. That means everything is covered. So my domain is all real numbers. So now let's find the intercepts. My y-intercept, I'm only going to worry about, so y-intercept is when x is equal to 0. So I only have to worry about the function when x is equal to 0. On the top function, I have x is less than 0, so I'm not going to check that one. I'm only going to plug it into the part of the piecewise function where x is equal to 0, and that's in the bottom part. So this is going to be y is equal to the cube root of 0, which is y is equal to 0. So I should have a y-intercept at y is equal to 0. Now, if I want to find the x-intercept, I'm going to set y is equal to 0. So my x-intercept, if I check the top part, by the way, if you know this is a reciprocal function already, you should know that there is no x-intercept for the top, but let's go ahead and check it. So I have 0. So this is when y is equal to 0. 0 is equal to 1 over x. Okay. Now, is there a number that I can plug into x to make this 0? No, this does not make sense, right? Because if I multiply both sides by x, what do I get? I get 0 is equal to 1. And that doesn't make any sense. So there is no x-intercept on the top function. But if you know the library of functions, you should know the reciprocal function has no x-intercept. Okay? Now, I'm going to plug it into the second part, and I get 0 is equal to the cube root of x. If I cube both sides, I get 0 is equal to x. Okay, so that is my x-intercept. So my y-intercept is y is equal to 0, and my x-intercept is x is equal to 0. So the last question we did in class, but I'm going to do it once again here so that you can see if you need to check your work again. Number 40, my piecewise function for number 40 is 2 minus x if negative 3 is less than or equal to x is less than 1. And then I have square root of x if x is greater than 1. So my domain, I have a minimum x value. That's negative 3. Okay. Now I'm going to keep going, and then I hit 1. And now look here. This is the one that's a little bit different than all the other homework problems. Because at x is equal to 1, there is no value for the function. The top one stops at 1, and it doesn't contain a value for 1. And the bottom part of the function starts at 1. Well, it doesn't really start at 1. It starts evaluating after 1. But x equals 1 is not included in the bottom part. So at x is equal to 1, there is no value for our function. So my domain, there are different ways to write the domain. You could write the domain such that for all x, negative 3 is less than or equal to x less than 1, and x is greater than 1, so I basically just combined the two. Or if you want to write it in interval notation, you could write it going negative 3, 1, parentheses, since it doesn't include the 1, the union 1, infinity. Okay? But now let's find the intercepts. The y-intercept is when x is equal to 0. So once again, if I look here, x is equal to 0 only applies to the top. So this is going to be y is equal to 2 minus 0. So y is equal to 2. So your y-intercept is at 2. Now to find my x-intercept, I'm going to set y is equal to 0. So I'm going to plug it into the top part of the piecewise function. I get 0 is equal to 2 minus x. I add x to both sides, and I get x is equal to 2. Now, this does not fall within the domain of the top part of the piecewise function, so this is not an x-intercept. I'm going to make a big X there because that doesn't work. Now, if I plug it into the bottom, I get 0 is equal to the square root of x. I square both sides, and I get 0 is equal to x. This does not fall within the domain of the bottom function, so this is not an x-intercept. So this problem has no x-intercepts. Has a y-intercept at 2, but it has no x-intercept. So that's it for the problems for this homework assignment. If you have any questions on the graphing, please let me know. We could go over it in class.